Okay, so for this last video, we're going to go through how to balance redox reactions by the half reaction method. These are not difficult, but they're kind of like little puzzles. So you're going to have to work your way through them. Each one is a little bit different. So I'm going to show you 2 examples in an acid solution, 2 examples in a basic solution to at least give you some skills that you can use. And then you are going to have to kind of work through each one individually to see how to attack it. All right, so just like with writing oxidation numbers, there's a set of rules for this that we're going to follow. So we're going to run through those real quick. The first thing you're going to do is you're going to write a half reaction. So that encompasses assigning oxidation numbers and writing half reactions, determining what's oxidized and what's reduced. All of that is in this one step of write the half reaction. Then you're going to balance all of your elements other than hydrogen and oxygen. Then you're going to balance oxygen by adding water to the opposite side. You're going to balance your hydrogens by adding H plus ions to the opposite side. Remember that H plus ions are what causes something to be acidic, so that does come into play a little bit later. You're going to balance the charges by adding electrons. You're going to multiply by the coefficient to balance your electrons. So if your electrons in your oxidation are 2 and then your reduction are 4, you're going to have to multiply your oxidation by 2 so that they balance out. If they're not different, then you can skip this step. Cancel out common terms and combine into one reaction. So if you're in an acidic medium, you stop there, you're good. But if you're in a basic medium, you have to neutralize all this H plus that you just added by adding OH minus to each side. So like I said, I'm going to show you 2 of each. So for this first one, we're going to start by writing our oxidation numbers of each part. So first I know the zinc is 0. This zinc is +2 because it tells me so. My oxygen here is -2, so that's going to make this -8. My hydrogen is +1. This is going to make this +3. So -8 and +3, this is going to have to be +5. All right, then over here, this is +1, so +3, so this is going to have to be -3. All right, so now I'm going to determine who's being oxidized and who's being reduced. So my arsenic's going from +5 to -3, so that's gaining a ton of electrons. So this is being reduced. And my zinc is going from 0 to +2, so it's losing electrons, it's being oxidized. Okay, so now I'm going to separate these into their parts. So my reduction half and my oxidation half. I'm going to write the parts in my reduction half, so H3ASO4, and then I'm going to leave a pretty good space, and ASH3, and then for my zinc, ZN, leave a pretty good space, ZN +2. All right. So now I need to balance anything that's not a hydrogen or an oxygen. So I've got 1 arsenic on each side, I'm good there. I've got 1 zinc on each side, I'm good there. So that part's pretty easy. So now let's look at the next step on the list. Balance my O's by adding water. So on this side, I have 4 O's. So that means I'm going to have to add, let me switch colors so you can see what I'm adding. I'm going to add 4 waters because each water is going to contain 1 oxygen. So now I've added a total of 4. All right. So then I need to balance my H's. Well, I had 3 and 3 to begin with, so I was balanced for the H's. So really only need to address what I just added. So I've got 4 times 2 is 8, so plus 8 H pluses. And then I need to balance my charge by adding my electrons. So this side is neutral, and right now this side is +8. So I'm going to have to add 8 electrons to balance that out and make this side neutral. And remember that this is the reduction half, so it's gaining the electrons, so the electrons have to be on the reactive side. So 8E minus. All right, so I'm good there. Then I'm going to come down to this one. Zinc to zinc +2, that means it's going to lose 2 electrons. That half was really easy. So I've got 8 and 2, and I'm going to need to cancel out those electrons, so I'm going to have to multiply this by 4. So this is going to become 4, this is going to become 4, and this is going to become 8. So now my 8 electrons and my 8 electrons cancel. And I don't have any other common terms I can cancel, so I'm just going to bring everything down and write it all together. H3ASO4 plus 4ZN plus 8 H plus yields ASH3 plus 4ZN plus 2 plus 4H2O. Now, because this is an acidic medium, I don't have to worry about the fact that I have extra hydrogens there. If this was in a basic medium, I would have to use this additional step 8, but because it's acidic, I'm good. This is my final answer. Sorry. All right, so let's do another one. So again, the first thing I want to do is I want to go through, I want to label my oxidation numbers. So oxygen, I know -2, 2 times 7, this is -14. I need to sit at a -2 charge, so I'm going to need for this to be 12. So that means each one of these has to be 6. I know that the chlorine is 1. I know that the chromium is 3, and I know that this chlorine is 0. So I'm good to go there. And also, again, this is an acidic medium, so that'll come into play at the end. So what's happening? +6 to +3, this is being reduced. -1 to 0, this is being oxidized. So I'm going to write my reduction half and my oxidation half. Cr2O7 -2 to Cr plus 3, Cl -1 to Cr, to Cl, let me just cross that out, to Cl2. All right, so first thing I need to do is balance. So I've got 2 chromiums and I only have 1 chromium, so I'm going to put a 2 here. That'll take care of that balancing. I've got 2 Cls and 1, so I'm going to put it here. That'll take care of that balancing. All right, so now let's work our way through the rest of the top. Chromiums are good. Oxygen, I've got 7 here, so I'm going to add 7 H2O. That's going to give me 7 oxygen. Now I have 14 hydrogens, so plus 14 H plus. Now when I add the electrons, what I have to watch out is I do have a charge on this side. In the previous question, this side was 0. This side is +3. So all I've got to do is make both sides equal +3. So right now, I've got +14 and -2. So I'm sitting at a +12. So I need to bring this down. Hold on, check my math. Oh, I'm dumb, sorry. It's not +3, it's +6, because that has to multiply. Sorry. So this is +6, I'm sitting at +12. I need to bring this down to also be +6. So I'm going to add 6 electrons. All right. So again, just one more time to go back through that. I'm sitting at 14, -2 is 12, -6 is 6. So this side is +6, and 2 and +3, this side is +6. All right. So now let's look at the other one. Cl, I'm good. I just need to add some electrons here. So I've got 2 Cls going to this, so what, 2 electrons? All right, now I've got 6 here and 2 there, so I'm going to have to multiply this by 3. So this is going to become 6. This is going to become 3. This is going to become 6. My 6 and 6 are going to cancel out. And then I'm just going to write it all together. So Cr2O7 -2 plus 6 Cl -1 plus 14 H plus yields 2 Cr plus 3 plus 3 Cl2 plus 7 H2O. Okay? And again, because I'm in an acidic medium, I can leave this the way that it is written. I don't have to cancel out these hydrogens. All right, 2 more. So these are going to be in a basic medium. So for the ones that are in a basic medium, the only difference is I do have to do that last step at the end where I cancel out those hydrogen ions. All right, so let's assign some oxidation numbers. We've got P4 by itself, so that's 0. And then notice this is the only thing here. So this P4, I can already tell is going to be both oxidized and reduced because that's the only thing that I have on my reactant side. It's going to make pH3, so this is +1, and so this is going to have to be -3. And then over here we've got -2, so that's 6, +1, so that's 5. And if it's going to end up as -2, this is going to have to be +3. All right, so 0 to -3 is reduced, and 0 to +3 is oxidized. All right. So my reduction half, my oxidation half. So for my reduction half, I've got P4 yields pH3. For my oxidation half, P4 yields HPO3 minus 2. All right, so let's do some balancing. I've got P4, so 4 P's and 1 P, so I'm going to put a 4 there. 4 P's, 1 P, I'm going to put a 4 here. I don't have any O's to balance with this first one. I just have hydrogens to balance. So 4 times 3 is 12. 12 H plus. 0 charge on this side, plus 12 here, so plus 12 electrons. All right, and then we come down to this one. P's are balanced. I've got some O's, so I'm going to have to add some water in here somewhere. So when I look at this, I've got 12 O's, so plus 12 H2O's. And then now I've got some hydrogen. Now I do have hydrogen on both sides, so I have to make sure that I'm counting right. I have 24 hydrogens here, and I already have 4. So that means I need 20 additional hydrogens, so plus 20 H plus. And then now I check my charge. This side has no charge. This side right now has 20 positives and 8 negatives, because 4 times 2. So if 20 positives and 8 negatives, that puts me at a plus 12. So I'm going to need plus 12 electrons to cancel that out. So now my electrons cancel. So we're good to go there. See if anything else cancels. So I've got 12 H pluses and I have 20 H pluses. So these 12 are going to get canceled out, and I'm going to have a remainder here of 8 H pluses. And everything else looks good. So I'm going to add these together. 2 P4 plus 12 H2O yields 4 pH3 plus 4 HPO3 minus 2 plus 8 H plus. Now, because this is in a basic medium, I have to do the additional step 8 and cancel out this H plus. So what I have to do is I have to add the same amount of OH to each side. And what that's going to allow me to do is H and OH, we know that makes water. So what I've really made, I'm going to cross it out and write it over here as water, is 8H2O. So I can cancel out some of this H2O again. All 8 of these cancel out, and I'm going to cancel some of these 12, and that's going to leave me with 4, because 12 minus 8 is 4. So now I've gotten rid of everything. The last thing I'm going to need to do is check to see if this can reduce. 8, 2, 4, 4, and 4, all of those are going to be divisible by 2, so I'm going to reduce everything down and then just rewrite it. So this is going to be 4 OH minus plus P4 plus 2 H2O yields 2 pH3 plus 2 HPO3 minus 2. And that's my answer in the basic medium. All right. So we're going to do one more, and then hopefully you at least kind of have some skills to get started. All right. Oops. Last one. So Zn is by itself, so we know this is 0. This Zn is plus 2, so now we need to figure out these guys. Minus 2 is plus 6. I'm sorry, minus 6. I need it to be minus 1, so this is going to have to be plus 5. And this is plus 1, so this is going to have to be minus 3. All right. 0 to plus 2, this is being oxidized. 5 to minus 3, this is being reduced. All right, so let's write our half reactions. So my reduction half is NO3 minus 1 to NH3. And my oxidation half, Zn to Zn plus 2. All right, so now check our balancing. N and N, I only have one of each. Zn and Zn, I only have one of each. So I can start with my other steps. I've got 3 O's here, so I'm going to add 3 H2O. Then here now I have 6 H's, but then I have an additional 3 here. So I have a total of 9 on this side. So plus 9H plus. And then neutral on this side. And right now I've got 9 minus 1 is 8. So I've got a positive 8. So I'm going to have to add 8 electrons. All right, so that side's good. Now let's look at this side. Zinc is going to make Zn plus 2, so it's going to lose 2 electrons. All right. And 2 and 8, I'm going to have to multiply this bottom one by 4. So it's going to make 4, 4. This is going to become 8. Those 8 and those 8 are going to cancel. And it doesn't look like I can cancel anything else the way it's written. So now I'm going to combine them. NO3 minus 1 plus 4Zn plus 9H plus yields NH3 plus 4Zn plus 2 plus 3H2O. Now this one is in a basic medium, so I've got to get rid of those extra H pluses by adding OH. So 9 H pluses means I'm going to add 9 OH minuses, and I'm going to have to add 9 OH minuses here. This is going to make 9 waters. All right, and I've got some water over here. So 3 of these cancel, and that's going to leave me with 6 waters. And that looks like it's it. So my final answer, NO3 minus 1 plus 4Zn plus 6H2O yields NH3 plus 4Zn plus 2 plus 9OH minus. Okay, hope that was helpful. If you have any questions, feel free to message me or see me in the morning.